Welcome to solverfy.
We're given a graph, and we're asked to use Kuratowski's theorem to determine whether this graph is planar. So the graph we're given has vertices A, B, C, D, E, F, G, H, I. And the vertices are connected as follows. Sort of a pentagon shape. And we also have A shares an edge with D. In fact, it shares two edges with D. It also shares an edge with F. We get this sort of star shape inside the pentagon. And we also have that B shares an edge with I. We see that D shares an edge with F. E shares an edge with G. F shares an edge with H. So this is the graph we're given. Now, to understand this graph better, let's just consider the graph where we remove all the curved edges from this graph. So let's get rid of the edge IB and the edge AD, the edge DF, and the edge EG, as well as the edge FH. This actually is going to help us in the long run. So we notice that there are 4 vertices now of degree 2. And these are B, E, G, and I. And now replace the vertex with the edges incident to the vertex by a single edge in the graph. So for example, we're going to replace the edges A, B, and BC by the single edge AC. And we see that this new graph is K5. Therefore, it follows that the graph contains a subgraph homeomorphic to K5, and therefore, by Kuratowski's theorem, it follows that the graph is non-planar.